Okay, legal disclaimer. So my employer is not associated with this joke, which is great news. I can tell you, for instance, that I support abortion. From a legal standpoint, it means when you present in reverse engineering and your company is not backing you, you turn to EFF. I saw they have a booth somewhere. Please give a warm round of applause for those people. There would really be no such talks, without their backing. I'd like to thank Christian Frischot for, leaving me from my cage at Salesforce today, opening the door of my cage and, patting me on the back nicely, tell me it's time to go. Last time they let me out was for Burning Man, that's why I'm dressed like this. So, I don't know if you see this, but from my point of view, this is super fucking impressive. And thanks for DNA Lounge for having us. This looks totally like, this clip from AC/DC. You familiar with this thing called Thunderstruck? Yeah? I kind of miss singing. We used to do that in Australia. You want to give me a Thunderstruck? You've been? Let's try again. You've been? Fuck yeah. So for the demos, if you like it, feel free to, thunderstruck me. Okay, if you want to leave right now, so the tool is free software. It's all real MIT BSD license. It's already on GitHub. So feel free to submit, feel free to, commit code and expand your own ideas and wish that I will maintain it. All right, so a bit of who am I? So I'm an immigrant. Absolutely. Thanks for adopting me. So I was born in France. No, that's not France. That's France. Exatamente. Then I moved to Brazil. Do you have anybody from France, by the way? Yeah, they're not invading us. Do we have anybody from Brazil? Yes, you from France. Quem é do Brasil? Grita aí, porra. Eu vi monte. Então, Right, so I'm very grateful to these communities around the world. That's why I'm mentioning them. The community in Brazil is like absolutely amazing. Then I moved to India. Yeah, anybody from India? All right. If you cross this man, he was my first boss in India. He's called Bikash. He's here this week. If you see him, please give him a beer. Okay, maybe half a beer. But yeah, be nice to him. And then I moved to the third world in Australia. Okay, so, the problem with those countries is that when they send the engineers, they don't send the best people. They send the exploit writers, the malware engineers, the reverse engineers. And I'm sure some of them are good people, but then bringing their problem with us. All right, so that's what we're going to be talking about today. There's a massive delay with the video, sorry about that. Go ahead. Okay, since we have some time to catch up on the video, I'd like all of you to give your hand to your neighbor. We're going to pray for the demo gods. You've got the goat? Yeah, we got it? Okay. So today I'm gonna introduce you a tool which has many use and many components, because like all good hacking tools, you don't know what you're doing before you actually try. We're gonna do a few things which are supposed to be super difficult problems in reverse engineering. we're going to start with libifying. So that's transforming an application into a shared library. So we can steal the function inside. Reuse the functions inside, of course. We're going to try to unlink binaries. So that's doing, when you compile source code, you typically first create object files, which is the output of the compiler, and then you link them together into a binary or a shared library. And we're going to try to undo the work of the linker. Then we're going to try to transform ELF files into, PE files into ELF, and then we'll do like batshit crazy stuff as much as we can. All right, the components. So the Witchcraft Compiler Collection has basically a linker, a compiler, and a dynamic interpreter. The difference with a typical toolchain is that the input is not source code, it's final binaries that you're trying to steal routines from. And it's built on top of Lua, which allows for easy extensions without any C, without any assembly or anything like this, and allows to do funny things for higher level purpose when you want to play with AI and things like this, which hopefully we'll let you cover. So the host currently has to be x86, 64-bit, but we'll see that we can actually debug applications for other platforms with the Witchcraft Compiler Collection natively on Linux, because it's cool. Okay, let's start with the libification thing. So basically the goal of this exercise is to take an ELF executable and transform it into a library so we can reuse functions in it. Let's start with demos. Okay, so the makefile contains most of the magic. Let me show you also the C code and comment along. So basically what we're trying to do here is to call a given function inside a binary called proftpd, which is like an FTP server. I'd like to call this particular function in it, PR_version get string, which does what? Print the version number. So this C code says what? We're going to use dlopen to load proftpd.so into memory, find the given function that we want to call, and just essentially call it. It's returning a string, and we're going to display the string. So what's a bit magic is proftpd is not initially a shared library. So we're going to take proftpd, copy it to /tmp, and libify it, so transform it into a shared library, which will allow me to then, if we step back, we're taking an FTP server, we transform it into a library, and then I'm writing my own C code to interface with that. Is there any IT teacher in the room? If anybody is in academia and stuff like that, make sure to check their pulse every minute or so. They might not like this too much. Okay, so I compiled it. You got the idea, right? We're going to take proftpd, and we're going to call a function inside proftpd which returns the version. Boom. So this one, for instance, is proftpd 1.3.5a. You saw what we did? Yeah, give me a thunderstruck, what the? Exactly. Okay, so that was too easy. So we know to transform applications into libraries. To do this, I packaged exactly 1 byte inside the header. So if you look at the solution, you might be like, yeah, that's super trivial. If you try to understand why this works, it's actually pretty deep. In particular, this doesn't work on a Linux kernel before 2.6.16. What we really did is transform the type of the object from etexec to etdin, which are like 2 types of executable binaries. essentially, the way we introduced address space layout randomization in the Linux kernel was by allowing executing shared libraries directly. It's a bit of a funny way to do it when you think about it, but it makes a lot of sense compared to recreating an entire toolchain, able to like generate executable that can have a base address randomized in memory. Since it's a fundamental property of shared libraries, if you compile, for instance, Apache as a shared library, so etdin, it will be randomized, and that's how we introduced randomization in the Linux kernel, and that's why this trick, which is not obvious, works. Any questions so far? Okay. All right, so we're going to do something a bit more violent. There's essentially two types of executables, right, in the Linux world and in the ELF world. So etexec, which is exactly the type we took for ProFTPD to transform into a shared library, and those which already support ASLR, and it's typically the case of Apache. All right. So how much did you pray the demo gods? Give your hand to your neighbor. If it doesn't work, it's your fault. I told you it wouldn't work. Okay, so truth is I knew this demo didn't work. The reason for it is the linker of the latest version of Ubuntu is basically broken. So there's a plan B. Okay. I'm going to connect to a remote server. I recorded this as a script, but it does exactly the same thing. Okay, so I'm connecting to a remote server. Even LS is slow in script. Okay, so make fails. If you Google like the error, that's very much a problem in the toolchain of the latest Ubuntu Xenial. I can do nothing about this. I mean, I don't care. So I compiled this on a remote server, and what I'm going to do is link my own C code against Apache directly to do exactly the stuff we just did with ProFTPD. Take a second to look at this though. Okay, I need to show you the source code first. Okay, the source code of the C program is very similar to what we just did. Okay, I want to call this function inside Apache. Come here. Come here. Oh. Okay, you're going to see this like in a minute. Basically, I want to call the function ap-get-server-banner, which belongs to Apache and returns its version number from my own C code. The difference with the previous case is I don't actually need to transform Apache into a shared library because it's already compiled with the SLR, so very much like a shared library. So I'm going to do something which is a bit unorthodox. I'm going to pretend I didn't understand that Apache was not made to be linked that way. Whoopa. And I'm going to link against Apache as if it really was a shared library. It's like the LD flags over there. Okay, so let's run the demo again, because it was cool. So what's interesting in those cases is that I did zero proper reverse engineering in terms of, decompiling, disassembling, or trying to understand like what are the calling conventions or complicated things like that from the functions I want to call from Apache. I just said like, let's just call it. Okay, and it worked. Thunderstruck. Yeah, so one thing super weird, if you look at the way the binary is actually linked, you can see that the second line is super unusual. The shared library is very much /usersbin/apache2, which sounds like, what the? That was too easy? Okay, we just solved a major problem of reverse engineering. Let's move to another one, which is bigger. So if I tell you reverse engineering, you might be thinking this. Like, yeah, I'm gonna take my binary and disassemble it and transform it back to C, and then I'm gonna recompile it. And truth is, like, this is a whole lot of work. So the typical way would look like this. If you take C source code, a normal toolchain like a compiler would produce relocatable objects that you will link into binaries. And the standard way to do reverse engineering is to go back to the source code. Oh, but we don't do that. Instead of doing that, let's just undo the work of the final step, the linker. Because if I get back the relocatable object files, I can embed them inside my own code. So I think I lost you a little bit. Let's imagine I'm studying an application, like I did that with my team last week. Like you have an SS7 stack, which is a super exotic network stack. And the main application doesn't work, but you'd like to steal functions out of it. Can we do that without disassembling? So the tool we're going to use is called WCC. It's the core compiler of the Witchcraft toolchain. And unlike a standard compiler, it doesn't take source code as an input, it takes binaries. But the output is very similar to what GCC would give you. And actually, the command line is made to be somewhat, somewhat, no, it's actually dissimilar. The front end is built on top of libbfd, which stands for BFD. Exactly right, big fucking deal. So the backstory, the guys at GNU were like, discussing having a layer of abstraction between file formats. And they were like, yeah, that's going to be super trivial. Let's call it big fucking deal. And when you look at actually at the complexity of the problem and the quality of the code, you're like, yeah, all right. The benefit is that my compiler, by leveraging libbfd, can cross-compile to other things and take other things as an input than ELF. So we're going to demo this. So let's take a binary, transform it back to an object file, unstrip it, potentially, and make a use of it. So if I take proftpd, we can run this demo right now. If I take proftpd, the way it's shipped, so the binary is doesn't have debug symbols and things like this. The binary has been stripped. And WCC is capable of analyzing this, unstripping it to an object file, and the neat trick is instead of recreating your entire toolchain is to fit into the existing elements. So I'm just undoing the work of the linker with WCC, and then I'm relinking very much with GCC to produce a shared library. Yeah? Too easy? 10 minutes? You're kidding me, I have 10 minutes left? Okay, let's get started. So let's cross a P and an ELF. This is my favorite slide ever. I think it makes a lot of sense. Oh. Okay, I'm just going to run that. I'm just going to do the demo. Okay, so if we go into Chrome, here I have a version of Chrome, and I have a version of Internet Explorer. One is 32-bit, the other one is 64-bit. I'm just going to type make. It should come, it's just slow. Oh, wow. And I just created chrome.bin and Internet Explorer.bin. Yeah. What the hell is going on here? You guys stop dosing the network when I'm trying to connect here? Okay, the demos are public, so you will have to trust me on that one. Okay. And you can see the slides either. Right. Amazing. Thunderstruck. Not sure what's going on here. So I have amazing exploit that I'm gonna explain you while typing them. Okay. Let's imagine we have a C source code. I lost my connection to the network. Maybe that's related. Come on. My brother, I may need you to action something. Okay, freestyle time. So you check the code and like, are we back? There's something on my screen. Okay. My favorite part of the tool is basically, once you know to transform something into a shared library, what would be interesting would be to map it in memory and in a state so that it can be executed without actually having to run execve. So the way to do this is basically to abuse a primitive called dlopen, which will solve the relocation for us and recursively load all the dependencies, fix the relocations, and do all the hard work for us of interfacing with a dynamic linker. I'm not sure what's going on. So that works wonders. You can do that with Intel application, and you can do that natively on a Linux machine, which is an Intel CPU. You can actually debug ARM applications too. So the way to do this is to, without a VM. So I'm debugging natively ARM libraries on my Linux machine, and I get the binary translation from like a weird mode of QEMU. I would love to demo you this right now. That I have interfaced with like a very cool Lua interpreter, which gives us the equivalent of reflection that exists in Java, but without the need of a virtual machine. So you can load shared libraries in memory, export the API, and directly call their functions. And I'm not sure I managed to demo you this. Come on. Can do something about this? Or fuck it? Yeah, all right. I'm with you. That was a great talk. Thank you for coming. Have a great day.
Thanks, Jonathan, on behalf of Fitbit and BSidesSF, we'd like to thank you and appreciate your time.
My absolute pleasure. Thank you, folks.